Welcome! Today we'll be covering infrared spectroscopy. Infrared radiation is just below visible light in terms of energy on the electromagnetic spectrum. Usually used in thermal imaging to spy on people, but we're going to look at an alternative use, how it can be used to help identify organic molecules. The bonds in organic molecules absorb infrared radiation. Different bonds will absorb infrared radiation of different wave numbers. This is why organic molecules make great accomplices in crime. They're good at taking the heat. For example, ethanol has a few different bonds which can absorb infrared radiation. The CO bond will absorb between 1000 and 1300. The CH bond between 2850 and 3100. And the OH bond between 3200 and 3500. Starting at the beginning then, a scientist takes the sample, puts it into the IR spectrometer. This will blast the sample with infrared radiation. It's linked to a computer which can produce a lovely spectra which we can partially interpret. A couple of things to note before we start interpreting the spectra. The troughs are called peaks, the wave number descends from left to right, the chemists are rebels who can't be tamed. Below 1500 is called the fingerprint region. It's too complicated for us to interpret, though the old school chemists of the 1940s gave it a go. Modern day we just leave it to the computers which can identify the molecule by comparing it to a library of known samples and coming out with a probability of it being a specific molecule. So we could look at it as if we aren't intelligent enough to do it. However, all it really means is we are good leaders who delegate the task to the most competent thing for the job, which in this, like 99% of all other instances, is an inanimate object. Let's interpret the spectra. First, get rid of the stuff below 1500. That looks like everybody's Aunt Lorraine at the free bar of your distant cousin's wedding. A mess. Next, find some peaks. The one here is the only one present on this spectra. It's between 2850 and 3100, so probably from the CH bond. Most organic molecules will have this. Now, as no other significant peaks are present, we can tell it's probably from a hydrocarbon. The peaks can get a little bit convoluted, so I like to cheat a bit and think, what does this peak look like? And the CH peak tends to look like the Queen has fallen over, which is to say, an upside down crown. So here's another one. Again, get rid of the fingerprint region. Now this time we have two significant peaks. No surprise to anyone that the CH peak is here, as it's in most organic molecules. The new peak is a sharp one between 1640 and 1750, which corresponds to a C double bonded O. With those two bonds, this spectra probably came from a carbonyl. That's an aldehyde or a ketone. Now we know the CH bond looks like the Queen had an accident. The C double bonded O, however, looks more like King Arthur is going to attempt to yank it out of a rock. Another. Get rid of the fingerprint region. And here is the CH bond. This time there's a fairly large peak just to the left of the CH peak. If you look closely, it's between 3200 and 3500, so corresponds to an OH from an alcohol. The rest of it is insignificant, so we probably have an alcohol. Now, I know you've already figured out what the OH from an alcohol peak looks like. It's obviously the tongue of the overly keen to share its own saliva with you dog that we all have come in contact with during a social event we didn't even want to attend. Last one, join in if you know the lyrics by now. Ignore the fingerprint region. Find your CH peak. It's normally there as its schedule, like mine, is pretty bare and it literally has nothing else to do but show up in spectra. I can see the return of the C double bonded O peak. Finally, there's a thick with two C's peak between 2500 and 3300. The scientific term is broad, but I didn't want to cause it any emotional damage. And this shows the presence of an OH from a carboxylic acid. Carboxylic acids also have a C double bonded to an O, which we found the peak for earlier, therefore this spectra probably came from a carboxylic acid. Somebody needs to look after this woman or she's going to hurt herself. King Arthur hasn't managed to pull it out this time from the stone. And the OH peak looks like Gunter flipped the Ice King's mountain upside down. The important parts for those who skip through the video or stop listening. Organic molecules can absorb infrared radiation. Computers can use this to identify molecules using the fingerprint region, but we should leave it to the computers because we will just upset ourselves if we try. And the best we can do is to determine the functional groups present from the other part of the spectra using the corresponding wave numbers. And that's infrared spectroscopy. Congratulations! Today you did a science.